This lecture introduces the Poisson distribution and Poisson regression model. So the very beginning, I want to talk a little bit about history of Poisson distribution and count regression models. Poisson distribution is considered to be the most important baseline probability distribution for count regression models. And it is believed that in 1837, French mathematician Simon Denis Poisson worked out the distribution using the number of wrongful convictions as an example in his famous book, Research on the Probability of Judgments in Criminal and Civic Matters. And the first serious application of this distribution is in 1898 by a German applied statistician von Borkwitch in his book translated into English, The Law of Small Numbers. And in that book, von Borkwitch used Poisson distribution to fit the number of Prussian cavalry soldiers that died of horse kicking. So what is Poisson distribution? Poisson distribution argues that, or assumes that, only variation is due to randomness among individuals in the population. How about Poisson regression model? And Poisson regression model adds additional information, argues that, well, it's not necessarily just the randomness that creates the variation in the Poisson distribution. It's also about observed heterogeneity, just a fancy term for example, individual characteristics. Okay, and also we have negative binomial regression model, and the negative binomial regression model adds unobserved heterogeneity to the model. So it uses some introduces some unknown parameter as a variable and tries to estimate that unknown parameter as, the collection of unobserved heterogeneity, basically unobserved, for example, for individual characteristics. And the negative binomial regression model often used to account for excessive zeros. And for count response variables, it's very common to find that there's a large number of zeros. And Poisson regression, Poisson distribution is deficit in explaining that kind of excessive zero. Negative binomial regression model is a nice regression model used to specifically, quite frequently, to address that kind of problem. Okay. And next type of model is in general called zero inflated count regression model, including zero inflated Poisson regression model and zero inflated negative binomial regression model. And the zero inflated count regression model adds what is called discrete observed heterogeneity into the regression model. And we're not going to put much time actually on this type of model, okay? But they're becoming popular. So my class and my lecture focuses on the Poisson distribution, Poisson regression model, and the most popular, shall I say, one of the most popular count regression models, the negative binomial regression model. Okay. And here, zero inflated count regression model is also frequently used to account for excessive zeros in the count response.